Welcome everyone. In this session, we're going to learn how to defuse the time bomb. Of course, I'm talking about that old QAD server that you should have upgraded years ago. Just to tell you a little bit about myself, in case you've never heard of me before, my name is Nectar Daloglou. I'm the president of OmegaServe and senior Progress DBA. I've been working with Progress and QAD for well over 20 years. I started off working for a software company that made the configurator product for QAD. I also worked for QAD for a number of years. I've been performing over the years numerous database administration related tasks, from installations, upgrades, migrations, performance tuning, health check, anything database administration. I've pretty much done it and continue to do it. Just tell you a little bit about OmegaServe. So we are a North America based DBA consulting company. We offer managed services, 24/7 monitoring and support, migrations, health check, business continuity planning and implementations. Our goal is to maximize uptime and performance. We want to help you achieve those 4 nines or those 5 nines. And while your system is available 24/7, we want to make sure it's performing at its best. We're also specialized in QAD, and we're an official reseller of ProTop, which is arguably the best monitoring and alerting software for your QAD environment. And specifically at OmegaServe, we've written monitoring specifically for QAD within ProTop. So not only do we monitor the open edge components, but we also added on monitoring to monitor your QAD system. This is what we're going to cover today. We're going to go through the discovery and planning, the migration process, post-migration, and finally we're going to end with a Q&A session. Although feel free to ask any questions you'd like in the chat. I'll even pause briefly at certain points to allow some time to ask questions. And I'll try to answer as many questions as I can during the presentation in the chat. Just a little disclaimer, your mileage may vary. So what that means is what I'm going to cover in this presentation may or may not apply to your environment. There's many variables in any particular system. Different hardware, software versions, add-ons, customizations, and other aspects that make your environment unique. And so the advice I'm going to give you may or may not apply to you. But there has been similarities throughout the many migrations I've done. So hopefully you'll get some good use out of this presentation. Also keep in mind, this is just a high-level overview. We only have an hour. I can't go through all the details, but I'd be happy to discuss with you any migration challenges you may have offline. So who is this presentation for? So as the title shows, it's primarily for migrating HPUX to Linux, but not necessarily. If you happen to be planning a migration in the near future, whether it's from another Unix flavor, AIX, Solaris, HP of course, going to Linux or going to Windows, or Linux to Linux, if you have an old Linux server, then hopefully you will get some good benefit out of this presentation. Let's have a little bit of fun. So very recently, I helped a customer upgrade their QAD system from an old HPUX that was plagued with hardware issues. And we recently migrated. So who can guess what the Progress version and QAD version is? Enter it in the chat and we'll reveal the answer at the end of the presentation. So why do we want to upgrade? Well, I wish servers were made to last forever, but unfortunately they don't. Even though there's redundant components, many of those components can fail and continue to fail, whether it's the power supply, memory, CPU, motherboard components, especially components in your disk I/O subsystem on your hard drives. It could lead to loss of files or worse, data corruption, or corruption that you don't notice until many weeks or months afterwards. There's also loss of performance. So the performance between a new server and even a server that's 3 or 4 years newer, it's just night and day. The benefits are tremendous. So what do these outages mean? Well, they can cause disruptions to the business. Long outages can affect the business very negatively. Shipping can get paralyzed. The work can get backlogged. MRP failures. I mean, the list goes on. QAD cannot be down. And as an end-of-life system, support is limited. Getting maintenances can be very costly, and even finding parts can be a challenge too. So here's some of the things that can impact QAD when it stops working. I mean, people can't do their job. Users can't log into QAD. There's loss of time. And once the system comes back up, everybody is just rushing to redo their work, and that adds risk of mistakes. And of course, they're unable to ship to customers. I mean, they can affect the bottom line. It can negatively affect your fulfillment obligations, and lose your reputation as a reliable supplier. Also makes everybody's jobs very stressful. And I mean, it affects in the end, it affects the bottom line. There is clearly loss of revenue when an outage occurs, especially a long outage, a long unexpected outage in your QAD system. Now, particularly with HPUX, there is an end of support date in 2025. The last shipment of any HPUX is going to be in July of this year. And after that, it's going to get very expensive to maintain it, just to keep the lights on, let alone all the outages that will be caused from the fact that the system is very old. Also, the software running on your system, once you decide to upgrade, well, I mean, there's a good chance, very good chance, that software won't be compatible on the new hardware platform. So it's a problem you need to address sooner rather than later. When it comes to performance, as I mentioned earlier, there's a tremendous performance gain going from an old HPUX system to a modern Linux system. So in our monitoring tool ProTop, we have a metric that we call BOGO MIPS, which is basically millions of instructions per second. From Progress's point of view. This is Progress processing millions of instructions, and based on that, we establish a score, and that gives us an idea, how much CPU throughput do we have on the system. So comparing here in the old HPUX, we're looking at a BOGO MIPS score, a variable all over the place from 0.4, 0.6. And on the new system, we're at a 5, a steady 5 or 6. Even on some newer systems which I recently upgraded, I've even seen this value on 8, a solid 8. So tremendous performance improvements going to a new system. Now, why Linux? Why not Windows? Why not another Unix flavor? Well, the main reason, cost. It's a lower acquisition cost, lower cost to purchase a server. You can purchase a commodity server to run your QAD system with a lower maintenance cost. There's no specialized staff. You don't need to hire an EIX or an HPUX expert. And it's not a proprietary skill set, nor is it on a proprietary hardware. It's also a smaller system, which means less power, less cooling, less data center space. And you're also not locked into that one vendor. Another great thing is the ease of transition. So anyone familiar with Unix, whether it's HPUX or AIX, has a shorter learning curve going from HPUX to Linux. Now, don't get me wrong, there are differences, and I highly recommend taking a Linux course, even if you're an expert on Unix. but it makes the transition easier, it makes migrating the scripts easier, and QAD will not only run on HPUX. In some cases, you could even run the code, the compiled code, on a newer version of Progress, and I'll get into that later on. Progress itself, it's not a simple copy and paste. You do have to reinstall Progress, and you do have to do a dump and load on the database, which I'll cover real soon. And it's also nice going to Linux because you have that option of virtualizing. And with virtualizing, you have other benefits such as scalability, disaster recovery, and also Linux is just a very wide used modern system. And we know for a fact that Progress and QAD does a lot of testing on Linux. Now let's get into discovery and planning. So the first thing we want to do when we're planning a migration, we want to assess the load requirements. We want to look at the current load and assess, what is our future growth going to be like? Are we going to add more users? Are there going to be more nightly batch processing? We also want to do some load monitoring and load testing on the machine just to get a baseline to see where we are and where we need to go. Once we've decided that, then we look at the hardware options. And there are pros and cons into these three options. So you can go with a bare metal, which means installing everything on the machine as is, no virtualization. And this has some benefits, especially on performance, because basically the entire hardware is dedicated to that QAD system, to that Red Hat installation. On the virtualization side, you have the option to scale. You can rapidly deploy this environment, and it'll allow you to support your old hardware, old versions much longer because you're no longer tied to the hardware. You're running virtualized. And it opens up new options for disaster recovery and high availability that you didn't have or were much more expensive on bare metal. And when it comes to the cloud, not the QAD cloud, but I'm talking specifically about AWS or Azure, your scalability options are basically limitless. As much as you're able to afford, you can add more cores, more memory, faster disks. I mean, the options are almost endless. And another feature of it, your infrastructure, a lot of your infrastructure is all outsourced. So they'll take care of any hardware issue, any hardware related infrastructure. Now, some of the key hardware components. So you want to size your memory, make sure you have enough memory, allocate enough memory, but not to a point where you start swapping to disk or paging to disk. That can be problem. On the CPU side, one thing to watch out for, you don't want to go with too many CPUs, rather go with a faster CPU to get better performance. If you load up a machine with 8 CPUs, 20 CPUs, 36 CPUs, it's not going to run any faster. In fact, you may even get yourself into trouble, especially when you're going into a NUMA architecture machine. So faster CPUs are usually better. I would much rather prefer a 4-core CPU at 3 gigahertz versus an 8-core CPU at 2 gigahertz, for example. Now, depending on the system and the number of users, of course. Disk I/O is also a big one, very important. So you want to make sure your disk I/O is fast enough and able to perform at least what it was performing before. And something to look at both from a regular day-to-day activity and also, do some load testing. How are the disks going to perform under heavy load, such as month end or while you're running a database backup? And of course, the network. Everything is tied to the network. So if you're running .NET over the network, over the WAN especially, you need to look at these components as well. You need to locate all your integration points. Anything coming into QAD or going out of QAD, you need to find out. I mean, you're going to migrate to a new system, you better reestablish those integration points. Whether it's QExtend, EDI, connections to the bank, SAP, BizTalk, payroll, and any other third-party apps, you need to identify them so that you're able to reconnect them to your new machine. Next, you want to do a system inventory. Identify all your QAD applications, all your components, your third-party applications, your scripts, your custom code, any software compatibility issues, whether or not the software will be compatible on the new Linux system, if you need to go to a different software, if there was some software that was helping you 10 years ago, no longer available in Linux. So these are things you need to look at. Also identify all your users and your printers, and in the end decide what stays and what goes. You don't need to necessarily migrate everything. I've seen some over-engineered scripts that just don't make sense anymore in today's world. After imaging, for example, there's been numerous scripts written on after imaging, and most of after imaging is managed by the AI management utility in Progress. So stuff like that we don't have to worry about anymore. Check your QAD compatibility. So QAD has a nice tool, and that's available on their support site, where you enter your QAD version, your components, and it suggests what Progress versions and OS versions are supported. So a nice little tool before you upgrade. You also want to make sure you check your Progress version. So I'm going to move out of the way for a second. So as you're upgrading, you want to make sure you choose a long-term supported Progress version. You don't want to be starting an upgrade, and then by the time you get to that upgrade or that migration, you realize that, hey, that version is going to get decommissioned. It's happened before where we were upgrading a customer from to 10.2a, and the migration took a few months, some regression testing and things like that. By the time we migrated, 10.2a was already labeled as retired. So check out this table on Progress's website. Make sure you choose a long-term version for your QAD environment. So to summarize, as part of our discovery, we want to assess the current load, locate all your integration points, take inventory of all your software, and finally check the compatibility. So I'm going to pause briefly. If there's any questions, please enter them in the chat. All right, next we're going to look at the migration process. So when we're doing a platform migration, if we're going to move to Unix to Linux, we need to do a database dump and load. And when we do this, part of validation is validating the record count, whether it's been a success or a failure, among other things that are involved. But basically, dump and loading means dumping the database files into what we prefer to do what's called a binary dump, which is much faster than another method that you can dump, which is an ASCII dump. Copy those files over to the new system and load them into the database. And what's great is that it gives us an opportunity to reorganize the database structure, and optimize it better for performance. That means choosing an optimal records per block, using type 2 storage, and eliminating any schema area table or indexes that you might have. And also, if you're using SQL, don't forget about SQL. There are SQL settings such as permissions, table views, etc., that you have to dump out separately from your usual dump and load, and make sure that they exist on the new system. So why is setting the records per block important? So the records per block is indicated in the structure file. It's basically the second digit in your area. So the first digit is your area number for transaction area number 7. And the next digit is 128, which means 128 records per block. Now, when you're setting this, you don't want to do a one-size-fits-all, which in some cases may work. But if you choose a records per block that's too large, it can lead to record fragmentation. And that means slower reads from your users when you're running a report, for example. And if your records per block are too small, well, it creates another problem. It leads to wasted space. So you end up using more database blocks for those same records. Now, why is that a concern? If you need to read more blocks, well, it's going to take longer to retrieve the records. Those same amount of records are going to take longer to read because you have to read more blocks. So I'll give an example of wasted space. So a few years back, we're looking at an audit database in QAD. And at the time, the audit area, had a records per block of 8 by default. And the table had grown to 11 gigs. Just by changing it to 64 records per block, we reduced the table size to 600 megs. Not only saving on storage, but making the reads on that table a lot more efficient. So very important. And also, the records per block may or may not make sense when you migrate to your new system because of the database block size. So if you have a database block size going from 8, for example, from HPUX, and then going to a typical 4K block size, while your records per block that were tuned for 8 are not going to be tuned for 4K block size. Also, what you want to make sure that you're loading into a type 2 storage area. Make sure you're loading into type 2 storage areas. So QAD in the modern versions have solved this problem, and they've been using type 2 storage areas for quite a while. But one particular point to pay attention to are your custom site databases. So I've seen a lot of environments where the site databases, there's absolutely no tuning or optimization. So this is a good time to do this. Make sure you use type 2 storage areas. And what type 2 storage areas allows you to do, basically, it stores all the records contiguously in the area. So rather than creating the records and your indexes all over the database in one big melting pot, creating scatter in your database. So years ago, we had to do a dump and load every year just to eliminate this problem. So we don't have to run a dump and load as often with type 2 storage areas. So all your records are contingent. So when you're reading ABS master, for example, or XX ABS master, well, you're only reading records pertaining to that table. You're not reading anything else that has no value and that causes more of a performance impact. There's also brand new parameters in 11 and version 11 and version 12. And some of those parameters include a nice parameter called SQL width update and SQL truncate too large. So these are specific to SQL. So if you're using SQL, definitely consider those. So what these do, basically, they eliminate the need to run dbtool once in a while because while 4GL records in the 4GL world and don't have this particular width limit, in the SQL world, you have to run dbtool once in a while to increase your SQL width. And otherwise, users will enter new records and they'll get this error message periodically, and that error message won't get fixed until the next dbtool run. So by automatically extending the SQL width, it's one less problem we have to worry about. Also, while you're running a pro backup online, Progress will back up your BI file, and while it's doing that, basically everything will stall. So if your database BI file happened to grow for whatever reason, it happened to grow into 4 gigs, 6 gigs, you're running your online backup, and you have to, and your database is just pausing at this point. There's a new parameter over here that basically eliminates the stall caused by your BI backup. That's a nice parameter. Another great performance parameter is called LRU skips. So using LRU skips, for example, has eliminated a lot of the performance issues we've had in the past, specifically to latch contention on the LRU latch. So it's a great parameter to enable on your new system. What I like to do, if you happen to already have ProTop, you can run ProTop's automated health check. So this is a paid feature, but what it does basically, it goes through all your parameters and makes recommendations for your environment that you can benefit from. Now, migrating to QAD. So when it comes to the application code, it's pretty much platform independent. So you can grab the QAD code in most cases and copy it on the new system, and it will run. Even compile, even in some cases not having to compile. So we've had a customer that needed to upgrade but didn't have good source code and needed to upgrade from 10.1c to 10.2b at the time, and they were able to run the new R code in the new the original R code in the 10.2b environment. Not something I recommend, this customer, because they had to migrate and they didn't have a good source base to migrate from. But all this to say that the application code is generally platform independent. Even your .NET system, you can pretty much copy over from Unix to Linux, and after some configuration changes, which I'm going to go through, it can run just fine on your new system. So when it comes to .NET, if you're changing hostname, there are hostname settings at the client side called the home server config, and that points to your home server, your Tomcat server. So you'll need to change that. On the Tomcat server itself, there's some configurable XML files that also contain the host name, and also the command line syntax. For example, on HPUX, logging in, you might have a £, in Linux you might have a $, or the other way around, I forget. And also there are some changes at the database level, database server level, that will need to be changed. If you happen to change the Progress app server name, for example, that would be in your ubroker.properties file. On the QExtend inbound side, if you're migrating QExtend inbound, so there's also some settings in Tomcat that will need to be changed. And if you happen to be using generalized codes that point to a particular host name, then that also will need to be changed. And with QExtend outbound, so here's what you need to change for that. So there's a file inside Tomcat, environment manager.xml, that contains some settings that you'll need to change if you happen to be changing your host name. Now, some notable differences between HPUX and Linux. So as I mentioned, the learning curve can be small going from HPUX to Linux, but there's a few differences worth noting, especially while you're adapting your scripts to run on Linux. So you have the shell path that is different. So by default, HPUX's shell can be the Bourne shell, or in Linux, it's Bash. The path to your binaries, your binary path, for example, if you're running gzip or whatever, so the path to these files may be different from HPUX to Linux. And your login scripts, if you happen to be converting over or copying over all the login scripts from HPUX or any other Unix system to the new Linux system, you have to remember that the login script in Linux is bash_profile. Also, the installing software is different. You have the RPM tool in Linux. The system logs are in a different location. The file system listing is different. So in HPUX, we typically run a BDF command, and we could run a DF command, but it's not the same output as Linux's DF command. So be mindful of these changes. Also, the SAM management console it's not there in Linux. In Linux, we typically do everything through the command line, using command line tools. There are admin tools that are available, but we typically run everything through the command line. And the system initialization is different. So on the newer versions of Linux, there's something called the system CTL, and that's where we set up components to automatically start up or shut down as the system stops or starts. Another interesting Linux feature is a self-preservation process called the out-of-memory killer. So what this does, basically, it's going to look for if you're in a situation where you're consuming too much memory, it's going to look for the process that's consuming the most memory and kill it. And typically, this is your Progress database server, your _mproserve process. And then, it'll just magically disappear. And then after some digging, you'll find in your log file that, hey, there's an out-of-memory kill, process ID 595, whatever. And find out that your main process has been killed. So it is a value, so the killable score, if you will, it is configurable. You can set up a value inside /proc/ the name of your process /OOM_ADJ adjust, and you can adjust the kill score from a -16 to a +15, or set it to -17 to avoid the process getting killed altogether. But these are typically just band-aid solutions. I mean, the real solution is, don't over-allocate memory. Find what's consuming too much memory and make adjustments as needed. So next, you're going to go through your testing phase. You want to make sure all your key applications are tested, all your key menus are tested. Have a test plan available, documented. Test all the integration points to and from the new machine. Make sure they're working, there's no compatibility issues or things like that. And you want to also make sure that you test and document your recovery procedure. So what better time to test your recovery procedure than while the system isn't live? Because once it's live, testing the recovery can be challenging. You'll have to schedule an outage, and that adds risk into testing this on your production system. While doing it on your pre-production system, it's a good idea. You have that luxury. Go ahead and test your recovery procedure and document it very well, and document everything as you go. As a matter of fact, it's also a good idea to do some performance testing. So you may have purchased a brand new machine, you've added whatever cores you needed, disk I/O. You want to make sure it lives up to its expectations. A lot of times I've seen that it's been a configuration related issue and the machine performance just didn't deliver. So it's important to test your performance, and while you're testing, establish a baseline. Where you are, where you're looking to go. There are some great tools out there that you can use to test performance at the database level. There's Sync.io, which is used to test unbuffered writes to Protop. So basically what it does, it creates a 100 meg file in an unbuffered way. And this is how pretty much all databases write to disk. I mean, it needs to guarantee integrity. It needs to guarantee that the records made it on the disk. And there's no better way to do this. I mean, there's a great way to do this is by growing the BI file, growing a 100 BI file, 100 meg BI file, and measuring how long that took. There's the free ATM utility that will test your transaction throughput on your machine. If you run this, make sure you run it while AI is enabled, so AI adds this extra overhead. There's Read Probe, which is available for free within Protop. And this will test single-threaded rapid readers. It's a good test of read throughput on the system. And a great way to compare your old system from your new system. There's also a free utility called Spawn. And what this does, as the name suggests, it simulates a whole bunch of users logging in that you can configure to run sales order maintenance screen, for example, and connect to the database and simulate some load on the system. And it's also a good idea to leave Protop running for a number of time and look at the performance, the long-term performance. And you can go back and see if there are any hotspots that are identified. So for example, if you're migrating to an existing virtual machine host on a new virtual machine, while leaving Protop running there, you'll be able to see if there's any hotspots during any particular day, during the week, or any time of the night. Of course, this is a paid feature, but I highly recommend that whether you use Protop or not, I highly recommend that you look at performance over time and not just at that current moment. You also want to perform a dry run. You don't want to do your dry run during your go live migration. So you want to craft your migration checklist, refine it, and run this checklist from all aspects, including all the teams that are involved. So all individuals that need to perform tasks should be on that checklist. It's also a good opportunity to capture timing and decide if that timing is acceptable, if it's an acceptable downtime. I have customers that will give me a whole weekend to migrate, which is great. And other customers, they can't be down for more than a couple of minutes, and then we have to figure out other solutions to migrate. You also want to document your validation points. So what constitutes a successful migration? What validation points are you going to have in your migration? And then we have the go live migration. Before we go into that, before you perform your go live migration, you need to make sure you have a backup plan. So I've been to customers where at the last moment they had to back out because of some issue, some third-party application that wasn't well tested, and they had to revert back. Well, luckily we had this backup plan, and we need to do steps 1, 2, 3 and revert back to where we started. And you need to establish go or no-go points. So at what point do you continue, and at what point do you have to declare this, a failure or a do-over? Because it may not be worth risking trying to get something to work on the fly if there's unknowns that creep up. So very important, establish those go or no-go points. And also define, as I mentioned, define your validation points. So again, what constitutes a successful migration? So for example, on the database side, if our record counts are matching, we have a successful migration. And so it's up to the business also to determine what do they need to validate to make sure that the migration was a success. So in summary, when we're migrating, platform migration requires a database dump and load. We'll need to do application and performance testing, a dry run, and then execute the live migration. All right, post-migration. Hooray, the migration was successful. After you migrate, you'll have peace of mind and your users will be ecstatic. Not to mention the risk of disruptions to the business that you would have eliminated by migrating to new hardware. Now, after you migrate, you still have to continue to monitor, especially the first few days after the migration, in case some of those new parameters didn't have the desired effect with the real production load. And you make your adjustments as needed. But you still want to continue to monitor over time. Monitor for any particular changes in performance. And this is why historical trending is essential. Whether you use ProTop or any other tool, you want to measure performance over time because you want to be able to pinpoint performance issues when they happen, when they started happening. What is your baseline performance? When was your performance acceptable? When did the issue started happening? So very important to monitor over time. If you care about performance. So as I mentioned, we have a score that we call Bogle MIPS within ProTop, and it's available in the free version of ProTop, except for the historical trending. So this allows us to see CPU throughput, and we could see that clearly on the new server. It's much faster than an older server, and we look especially on virtual machines. We want to make sure that the system isn't over allocated on CPUs. So we would normally see like a zigzag happening if such a problem occurs, but it allows us to pinpoint where to look for what the problem could be. We also monitor I/O response time. So you see on the new server, your I/O response time can go from 5-10 milliseconds down to 0.6, 0.4, even 0.1 milliseconds. And these are basically random reads against a database that we monitor over time. We also monitor something we call user experience. We run queries against the schema tables in shared memory. And we also do this against client-server connections. And that will help us pinpoint to see if there's been any changes in the network performance. And of course, the SyncIO trending. So this is your unbuffered writes, how fast we can write a 100 meg file. And we monitor this over time. We look for any changes, any hotspots. If we happen to have any performance issues, any disk I/O related performance issues, it would show up in this graph here. So very important, whether you use ProTop or not, monitor this over time. We can also set up application-specific metrics. For example, MRP. If your MRP suddenly takes 10 hours to complete, when it used to take half an hour, you want to see whether or not this change was progressive, whether it went from 30 minutes to 8 hours in one day. You want to find out when the problem happened, how the problem happened, how progressive it was. You can monitor these things. You can set up application-specific metrics within ProTop, but only in the premium version.